The first thing we are looking at is the slope. If you recall, the slope formula is y2 minus y1, x2 minus x1. And this applies for problem number 1, problem number 2. If you take this, 5 minus 1, 2 minus 2, you get a 0 on the bottom, which means if you have a 0 on the bottom, you have an undefined slope. So you would just write undefined. Problem number 2, you should take negative 1/4, subtract from 3/4, 5/4 minus 7/8. What you get up top is negative 4/4, which is also negative 1. And then on the bottom, you have to find your common denominator. Your common denominator of 5/4 would be 10/8. And 10/8 minus 7/8 is 3/8. Cannot have a fraction on the bottom. You do the reciprocal, and your slope here is negative 8/3. Number 3, given the slope of negative 3/5 and the point of negative 2/4, find the second point on the line. So if you use your point slope formula, with what you have y minus 4 equals negative 3/5, and it would be x plus 2, and then you solve for y, you would get y equals negative 3/5 x plus 14/5. At this point, you can put any value that you want to in here for x. So if you put 0, another point would be 0, 14/15. If you put 1 in there, you would get 11/5. So all you do is put the x value that you choose into your problem. Questions? Okay, number 4, if you want the parallel line, you write the same slope, use point slope form, and you get y equals x plus 3. If you want the perpendicular line, you use the negative reciprocal, and you get the y equals negative x plus 7. For 5, you do the same process. The parallel line is y equals negative x plus 1. The perpendicular line is y equals x plus 1. Yes, plus 7. Okay, for number 6, all you do is plug these values in. For f of 0, you get negative 5. F of 3, you get 16. And f of negative 2, you get negative 9. For 7, f of 1, you get 3. F of 3, you get 1. And for f of negative 3, you get negative 1. Number 8 and 9, when you're looking, and 10, you're looking for the zeros. So you need to either use quadratic formula, you need to factor, or when you have 4, you can group. So number 8, my zeros are x equals 5 and negative 2. For 9, my zeros are x equals plus and minus 3 and 2. And then for number 10, I'd use the quadratic formula, and x equals 5/4 or 1.25 and 1. When you're looking at the points of intersection, when you have two graphs, you can do a visual if you want, but you set them equal. So to get you started, you would just set them equal. X minus 1 equals x squared minus 3. combine like terms, factor, and when I factored, I got x squared minus x minus 2. So though I know that my factors are x minus 2 and x plus 1. So that gives me the values of x equal 2 and negative 1. And then to get my y values, I would just pick a formula and put them back in. So I'm going to pick the line, it's the easiest. So I'd have, for 2, I would have y equals 2 minus 1, which is 1. So 1 point is 2, 1 that they meet. And then the other one is y equals negative 1 minus 1, which is negative 2. So negative 1, 2. Negative 1, negative 2. So to find the x and y intercepts, vertical asymptote and the horizontal asymptote, the x, there are no x-intercepts, so you can write none. For the y-intercept, it is 0, negative 4/9. For the va, it's plus and minus 3. X is equal to plus and minus 3. And then for the ha, it's y equals 0. So you use your rules, and it's y equals 0. For 13,
How did you get y equals 0 on that one?
okay, so for 13, your x-intercept is 4, 0. Your y-intercept is 0, 2/5, and that's reduced. Your va is x is equal to 5 and negative 2. And your ha is again y is equal to 0.
If we write it for the
Okay, on find the inverse, the basic thing that I want you to be able to do is to find the inverse, which means that you have to switch x and y. So your inverse for number 14 is the cubed root of x plus 7 is equal to y. And then 15, your inverse is y equals x squared minus 2. 16, your expression, you're taking 350 degrees and you're trying to take it to radians. So I have 35/18 over pi. And then for 17, you're going vice versa, and I have 100 degrees. Okay, so for 15, if you just switch x and y, you have x equals the square root of y plus 2, and then it's a minus 1 on the outside of the square root. So the first thing you're going to do is add 1. So I added 1. Okay,
You can write it like 17 or
okay, yeah, let's write it down here. So I think this is wrong. So you have the square root of y plus 2 at this point. Then to get rid of that, you square both sides. So there you go. You'd have x plus 1 quantity squared equals y plus 2. And then you'd subtract 2 to the other side. So you have x plus 1 quantity squared equals y. I apologize. Minus 2. Yes, minus 2. For 18, sine is equal to a half, or your sine of x is equal to a half. Absolutely. So if you use your chart, it's pi over 6 plus 2 pi x, and you add the 2 pi x to take care of any rotation or, yeah, going around again. And then it's also at 5 pi over 6 plus the 2 pi x. Okay, number 19, you would factor.
Wait, where did you get those numbers?
Okay, so then 19, you're going to factor, and you have cosine of x minus 2, and then you have cosine of x minus 1. And basically, when you set them both equal to 0, you figure out that cosine of x is equal to 2 and cosine of x is equal to 1. However, we know that, cosine is not equal to 2. So you just have to look at the values of where cosine is equal to 1. Yeah, so your values are 0 plus the 2 pi x, and then it's 2 pi plus 2 pi x, and that the 2 pi x again takes care of any extra radians. Okay, number 20, all you had to do was identify the amplitude, the period, and the frequency. So the amplitude in this case is 3. Your period would be pi. And then your frequency is 2 over 2 pi, which reduces to 1 over pi. For 21, your amplitude is 4. Your period is 2 pi over 3. And your frequency is 3 over 2 pi. It says without a calculator, find the value of the expression. You take the small number first. If you recall, this number is the square root or the cubed root or whatever you're looking for. It's the root. So you take the square root of 4, that's 2, and then you use the power, which is the number on top. So 2 cubed is 8. Number 23, the cubed root of 8 is 2, and 2 squared is 4. Logarithm 3 to what power is 81? 4. And then log base 2 of 1/16 is negative 4. Okay, so finally we're looking at 26. You have an exponential equation. In this case, your answer is x equal 3. Because your bases are the same, so you use the rule. And 27, 2 to the x equals 1 over 32. So 32, you know, is 2 to the negative 5th. And then when you have the same bases, you can cancel out, and x is just negative 5. The compositions. So if you do f odd g and then g odd f, okay, so the first thing you start with g. And you have the square root of x minus 3, and that goes in anywhere there is an x. So this would be the composition of f odd g. And there's really no way to simplify it. And then if you go backwards of g of f of x, you would have the square root of x plus 1 minus 3. But you can simplify underneath here, and you'd have the square root of x minus 2. Okay, on 29, it's kind of the same process here. If you go f odd g first, you have the square root of x minus 2, and you get to square it, and then plus 1. So when you square that, the square root goes away, and it's x minus 2 plus 1, which leaves you with x minus 1. You go backwards, in g of f of x, so you start with x squared plus 1, but then you're going to put the square root of it, and then minus 2. So you'd have the square root of x squared minus 1. Then your last thing, it asks for you to describe the graph. How would you make it? If you had an original graph of y equals x squared, how would you make it 2 times the original graph and shifted to the right 9 units and down 3? So you'd have y equals 2x minus 9, quantity squared, and then minus 3 because it's down.